Today we are going to discuss exponents and the rules of exponents and how they apply to different mathematical situations. What is an exponent? As you can see, it's a quantity representing the power to which a given number or expression is to be raised. For example, we have the base a is raised to the power of n. This means that we have the multiplication of a n times. Where a is the base and n is the exponent. Let's start with some examples. First, we'll use a base of 3, and our first exponent will be 1, which tells us 3 to the first power equals 3. We'll use the exponent of 2 next time. In the same base of 3, we have 3 squared, which tells us we have 3 times 3, which we know is 9. Let's use the same base of 3, and now an exponent of 3, which tells us that we have 3 times 3 times 3, which if you do the math equals 27. One more example for fun. 3 to the 5th. 3 times 3 times 3 times 3 times 3 equals 243. Thus, exponents can be used to condense multiplication. Now we'll review the rules that go along with exponents, including product rules, quotient rules, power rules, negative exponents, zero exponents, one exponents, and rational exponents. All of these rules we can see right here in this table to your right. We'll go through some examples of each one of these rules and then give you some examples to practice on your own today. Let's start off with the product rules. First, we're going to look at like bases with different exponents. For example, we have a to the power of n times a to the power of m. We'll keep our base the same and we'll add our exponents. So we have a to the power of n plus m. Let's look at a numerical example. We'll use 2 to the power of 2 times 2 to the power of 4. We have a base of 2, and we add our exponents of 2 plus 4. That gives us 2 to the power of 6, which if you put it into the calculator, gives us a value of 64. Let's look at our second product rule. Our second product rule has different bases, but the same exponent. So here we have a to the power of n times b to the power of n. Then we can multiply the bases and raise them to the power of n. Let's try a numerical example with this. We have 2 to the power of 2 times 3 to the power of 2. Here we take the two bases, which is 2 times 3, raise it to the power of 2, gives us a value of 6 to the power of 2, and we know 6 times 6 is 36. Try these 4 problems on your own. Remember, if your base is a number, you need to simplify your answer so there's no exponents in your final answer. Now we will look at the quotient rules. First, we have a to the power of n divided by a to the power of m. When we have a quotient rule with the same base, we take the base and we subtract the exponents. Let's try a numerical example. We have 2 to the power of 4 divided by 2 to the power of 2. So we take our base, which we know is 2, and our top exponent, which is 4, minus our bottom exponent, which is 2. This gives us a base of 2 still. 4 minus 2 for the exponents leaves us with a remainder of 2. And 2 squared is equal to 4. Let's look at our second quotient rule. For this rule, we have different bases, but the same exponent. So here we have a raised to the nth power divided by b raised to the nth power. Here we would divide both bases first and then raise it to the nth power. Let's do a numerical example for this problem as well. Here we have 8 to the second power divided by 4 to the second power. So here we're going to look at the bases. 8 divided by 4 to the second power. And we know 8 divided by 4 is equal to 2 to the second power. And 2 squared is equal to 4. Try these 4 examples using the quotient rules on your own. Make sure if your base is a whole number that your final answer has no exponents in it. For the power rule, we have a base raised to an exponent raised to another exponent. So here we have b raised to the power of n, all raised to the power of m. This equals our base being raised to the power of n times m. Let's try this with numerical values. Start with the base of 2, raised to the power of 3, raised to the power of 2. So here we have 2 to the power of 3 times 2. This gives us 2 to the power of 6. If you put that into a calculator, you come up with a value of 64. There are some examples on the next page that you can try. Try these 2 examples using the power rule. Remember, if your base is a number, your final answer should contain no exponents. We'll examine negative exponents next. We'll start with the base of b raised to the negative power of n. In order to get rid of this negative exponent that we have right here, we have to bring it down to the denominator. So here we have 1 over b to the power of n. Same with the inverse. If I have 1 over b to the power of negative n, in order to get rid of this negative exponent, I now have to do the inverse. So thus I have b in the numerator raised to the power of n all over 1, which we don't have to write because we know anything divided by 1 is still itself. So let's try this with a numerical example. Up top, let's start with 3 as our base, and we have negative 2 as our exponent. So once again, to make this negative 2 we have here positive, we have to shift this whole thing down to the denominator, which will look like 1 over 3 squared. And we know that 3 to the power of 2 is equal to 9, so our final answer would be 1 over 9, or 1/9. Let's do the same for the inverse. Let's start with 1 divided by our base of 2 to the power of negative 4. So once again, we need to get rid of this negative exponent here. So we're going to move it and do the opposite. Equals 2 to the positive 4, since we've moved it up to the numerator. Once again, that's the same thing as 2 to the 4th power over 1, which we don't need the 1. And we know 2 to the 4th power is equal to 16, and that would be our final answer for that. Here are some examples to try out using the negative exponent rule. Number 3 is a little bit tricky. Just remember where you move things to get rid of the negative. The next exponent rules we'll look at is the rules where exponents are equal to 0 or 1. When an exponent is equal to 0, the expression is equal to 1. No matter what the base is, if it's a number or a variable, anything raised to the power of 0 will always be 1. 0 raised to any power is always equal to 0. Obviously, because 0 times 0 times 0 times 0 is equal to 0. Now let's look at when we have an exponent equal to 1. When we have a base of b raised to the first power, our expression is equal to just b. Let's look at a numerical example. When we have 5 raised to the first power, it equals 5. How about when 1 is raised to the power of n? Then our value is still 1. 1 raised to any number will always be just 1, as we know that 1 times 1 times 1 times 1 still will always equal 1. Here are some examples that use the 0 and 1 exponent rules. Try them on your own, and remember, if your base is a number, your final answer should be a number. We will examine rational exponents later, but let's think about why exponents are important. As you can see from these different pictures, exponents are used in computer games physics, in determining the exponential decay, looking at radioactivity in different places, exponential growth, for example, human population, and the list of jobs in the middle: economists, bankers, financial advisors, insurance risk assessors, biologists, engineers, computer programmers, chemists, physicists, geographers, sound engineers, statisticians, mathematicians, geologists, and many more. So exponents are important. They're out there, and that's why we're learning them.